All right, let me catch you guys up to speed on what I've been doing. So I printed out a second, what I call intermediate bearing housing, which is this piece right here that holds the bearings. A second one so that I can use a second rod so I can easily replace it to put the new main rotor in, which is quite a beast. Anyway, I've been working on commutators, which I made one of these, which will go on the other side. But then I wanted to figure out a way to connect, to make electrical connection on this side, which is what a normal Newman motor does. You have a connection here. You run the commutator on this side, which is connected to the rotor in the center, right? So I built this guy, which is a stand for one of these brushes, and it has a spring in it. I 3D printed it out of clear clear filament, which came out really cool. So this goes in there. That guy goes together like this. This guy goes down inside there, and it will connect to a wire that will come out. So I have a hole in here somewhere right here, which will then connect to, I think, the negative terminal or the positive. Anyway, this guy, let me pull you up a little closer, goes here, press that down, slide it under, and it has an electrical connection there, which is almost no friction because you know these are made out of graphite or carbon, and I think that's going to work really well. And it's amazing because I bought a set of these guys really cheap on Amazon. Where else? Where you get ones with springs and ones without springs. So I chose the one without the spring because it has a good connection point. I take it out, it's got a really nice connection point right there that I can hook a wire to. And then I just took a regular spring, which, you know, semi fits. Yeah. So let me get that hooked up. Let me get the rod in there. Let me get the new rotor on there and see if we can't get this guy going. Stay tuned. Okay, so it was tricky, but I got this guy working. So this end goes to the positive terminal of the battery or the power supply. That guy gets pushed down and runs very smoothly. And I do have continuity between this end and the lead right here, which again will get hooked to the positive terminal. And then the negative terminal gets hooked to this top lead, and then the bottom of the coil goes to the commutator. Yeah, I think that's how it goes. At least that's how my very old traditional Newman motor diagram shows. Excuse me. I had to put you on pause there for a moment because I had a nasty cough. Want to buy some waffles? Anyway, so yeah, I downloaded this picture many, many years ago, and it has served me well. Anyway, that's how I'm going to set this up. I also got some comments and some feedback, one from, I think it was Free Energy or Energy Experiments, talking about Sky's Sky's commutator, the mechanical one that is triggered just by the spinning magnet. And I definitely want to try that. I want to try that one out and see how it's going to work. But I want to set this guy up first because I want to see how low of a voltage I can get this guy running at. Anyway, let me get the new commutator set up. And then I have to set the arm up, which is this guy, which I 3D printed. Very flexible. Will ride against the commutator like that. Oh, wait a minute, you couldn't see that. We'll ride against the commutator like that. And let's see what we got going here. Stay tuned. All right, so I didn't anticipate, as usual, the length of this rod. But moreover, I don't know if you can make that out. I think the reason why I didn't use this rod, even though it appears straight, I think you guys can see that it's bent. Or it has a slight wobble to it or a slight bend. Dag! And it would have been great. I'm still going to use this new mid piece. It's just that I won't be able to swap them out the way I anticipated. Anyway, no big deal. Stay tuned. Yeah, much straighter. In fact, it's completely straight, unlike the other one. That is one heavy-ass rotor. I don't know that this little thing is going to protect me, but I have faith that it's not going to come apart. Those bearings are nice too. Yep. And then this guy will go there up against the commutator, and this guy will go underneath here. Yeah. Let's get it together and get it running. Stay tuned. I wanted to make sure that the proof of concept would work with that thing there. 12 volts. You could see it's working. I really like that setup. That's really nice. And there's the new commutator. But again, this is just a quick test just to see if it would even work. Because I remember a while ago, I tried something like that and it didn't work. But that new rotor is flying. Anyway, just wanted to show you that this guy works. Stay tuned. I got to hook this guy up the right way. All right, so there it goes. I've got it. It's going really slow because I have it running on 3 volts. It's a really nice setup. Commutator, the commutator arm. Oh, wait a minute. What happened to the... Oh, shoot. Stay tuned. Oh, well. I had a piece of foil that wrapped around this head right here. Right now, it's just running off of the wire that's there. I don't know what happened to the foil. Oh, there it is. It's on the floor. All right, let me see. Let me put the foil back on there. Stay tuned. Yeah, I'm going to have to fix it better, but that's kind of how I had it. The foil was wrapped around and then pressed up against the wire. Right now, it's just, yeah. Anyway, that's running on 4 volts. Let me fix that, and I'll bring you back and we'll really get it going. All right, stay tuned. Okay, that's how it's supposed to look. That's 4 volts. Let's see if we can get it down. There's 3.1 volts. Now let's turn it up. There's 7.3 volts. That's really got it whipping too. There's 10 volts. I don't see, normally you see some sparking. I don't know if that's a good sign or a bad sign. All right, let's bump it up. There's 12.5 volts. I got to set it up now so I can get some output from it. I'm not pleased how this came out. You can see the hot glue on there. That's not how I wanted it to happen, but it's working. It's working really well too. I'm really happy with this setup here. Let's get it a little bit higher. There's 14 volts. Go a little higher. There's 16 volts. She's flying now. There's 20 volts, actually 19. All right, let's get it back. Let's crank it up a little bit more. There's 23 volts. Now you can see some sparking over there. All right, let's get it back down. That's kind of crazy. I don't need to be. There's 12 volts. And you can see some sparking a little bit on the 12 volts, but not by much. Yeah, I really like this setup. I know I've said that a couple of times, but oh, I think the commutator might have moved. All right, let me shut it down. I don't know what that weird sound is, but I think the commutator might have moved. Yeah, it did move. Because the commutator, the contact point has to go in parallel with the rotor. In other words, if the north is facing up, the contact has to be facing up. And it's funny because depending on what pole you're aligning it with will determine the direction of the spin. So right now I have it set up, and I'm not really sure which pole it is, but that's why I marked the bar like that. And it did move, so I need to fix that. Stay tuned, I'll bring it back shortly. Yeah, because that's how 12 volts is supposed to go. So yeah, the optimal placement of the commutator is important. And in this setup, it has to align directly with the pole. And again, depending on which pole I set it up on will determine the direction of spin. I don't know why I haven't played with this more. Now I got to set it up for producing some output. I have to get my, I have to look up the diagram on how to do that. And again, this rotor has, let me turn it off. This rotor has got 4 disc magnets. I think these are like 2-inch on both sides. So it's pretty heavy. Anyway, stay tuned. Oh, and I figured out why it's making that thumping noise. It's because the way I designed the commutator is flawed. I made it so that it had a flat spot on it to hold the foil. I should have just kept it round. So I'm going to print out a new commutator and not have that flat spot. I don't know why I did that. I thought, yeah, I'm not sure why I did that. Anyway, stay tuned. So I'm back in the office printing out the new commutator that I just talked about. I also printed out a new clear coil that I'm going to wind. And I've got some 28 gauge wire and then some 22 or 21. I'm not sure which one I'm going to use, maybe even 23, to make a bifilar coil. I also printed out a cup that goes in there that I'm going to this time fill with nails, or not nails, but small iron rods. I'm not sure what I'm going to use. I think I have a bunch of material I can use, fit them in there, and then pour resin around that. Or actually, I'm going to mix the resin with a little bit of the iron powder and pour it around there so I can take it in and out. This is the base for the commutator arm. I had printed out one and I forgot that I had it in vase mode, so it printed it out hollow, which is not really good. Anyway, just wanted to show you that really quick. Stay tuned. So it runs much smoother with the round commutator, obviously. That's 12 volts. You don't hear that thumping sound anymore. A little bit, but that's just the copper foil bumping up against the other copper foil because of the difference in height. But yeah, I don't even have to push it hard up against it. It can just kind of sit there. So what I also want to do is I have a little Zen moment there. I have the new circuit that you guys seen, the double, where is it? Come on over here. The double JL94. What I want to do is unhook all of this and hook one of the coils up to one side of the circuit and the other coil up to the other side, the way you would do a bifilar coil, and see how this runs. It ought to be interesting. She's flying now. Of course, we're over 12 volts. We're at 12.9. There's 12.2. Still running really good. I love this commutator setup, especially that thing over there. Almost no friction at all against that graphite brush. I think they're made of graphite. All right, stay tuned. So I've got it hooked up to both of these coils. And it's weird because I'm getting AC output. But yeah, it fluctuates between a small amount of voltage and a large amount. Let me see if I can pull this a little bit closer, see if that'll change anything. This is a 120 volt AC light, or 120 volt light. Let me hook a meter up to it and see what I'm getting. Hold tight. Yeah, so I'm getting anywhere between, it'll show 50 volts, and then it will show 4 volts. When it first started up, it was like 50 volts. Yeah, it's hard to get a reading on this because of the pulse. Anyway, it's pretty cool. And so what I want to do now is I want to hook up the dual JL94 circuit. Yeah, so it fluctuates between 10 and 20 and 25, and I suppose I could hook up a cap to this and smooth it out. Hold tight. All right, so I have it hooked up to a bridge rectifier and then hooked into a cap, getting about 50 volts, 49, 50, yeah, 50 volts at 28, at 12, I'm sorry, 12.28 volts going in. That's pretty cool. This is a 450 volt capacitor, 1,000 microfarads. Everything's nice and cool. $60 volts. Of course, that's because it's pumping into the cap. But what can I run off of that instead of the meter? All right, stay tuned. So now I have it charging up my super cap bank. So the max this thing can go to, in theory, is 16 volts. Because I have 6 500 farad capacitors in each of the slots there. And each one is rated, I think, for 2.7 volts, something like that. Let me see what we're up to. I'm going to have to put you guys in a stand here, if I can do it without screwing it up. There we go. And then let me adjust this like this. All right, let's see what we got here. She's up to 6 volts now. So unlike this capacitor, this bank's got some oomph. So let me see what I can hook to it. Stay tuned. All right, so what I want to do is I've got this guy running through, I've got it pumping into a bridge rectifier going to my super cap bank. It's charged up to 10 volts. What I want to do when this thing is fully charged is reverse it and see if I can run the motor off of the bank. So it's going to take a little while for it to charge up. So maybe if I increase the voltage. All right, we're at 24 volts going in now, so that should speed things up a little bit. Everything is still nice and cool. Oops. I think I messed up my connection here. Oh, it's still working, I think. Wait a minute. Oops. Sorry about that. Ah, yeah, it's still working. All right, let me bring it back when I get it up to like 15 volts. Stay tuned. So it's definitely cooking and my bridge rectifier is getting hot. It's up to 12 volts. Thought I smelled something. I think it's the bridge rectifier cooking. It's not that hot. It's hot enough. Up to 13 volts. This thing is nice and cool. Well, yeah, it's cool. But that bridge rectifier, I think it's seen better days. 13 volts. All right, we're gonna call it here in a minute. Let me at 15 volts. I'm gonna stop it. All right, let me bring you back. Somehow I turned my video off. I hope I got most of that. I put the stand down and the video turned off. Anyway, it's running off the supercap bank. It's been running now for a few minutes. And it's still running really good. It's funny because when I tried to measure the supercap bank while this is running, I'm getting the sporadic readings because of the pulsing. Because it's feeding back through the wires back into the cap. That is running surprisingly really well off of that. I didn't think it was going to run this good off of 6 supercaps. I love supercaps. Doesn't show any signs of slowing down. That's a song, isn't it? So before, once in a while, you hear me say something like, want to buy some waffles? Apparently, some commenter, some guy, I don't know, several videos ago, left a comment saying, I think we found a new spokesman for the Waffle House. I had no idea what he was talking about. And so I said, that's great. I have no idea what you're talking about. And another really nice commenter said, don't listen to this idiot. He's referring to your voice. So, and I guess it's a local thing because we don't have any commercials here in Northern California about Waffle House. So apparently it's a local thing where the spokesperson must have a real raspy voice. Anyway, that's why I'm playing into it a little bit. Want to buy some waffles? So here's the cup I talked about earlier for that new coil. I'm trying to figure out what I want to put inside there as far as the iron core thing. This thing is still running nice. It'll probably run for quite some time because I did have this thing running on 2.3 volts or like 3 volts. And again, if I adjust the pressure of the commutator, so it's just barely touching. Yeah, it's still going really well. Let me see if I can see how much is left on there. I don't know that I could do it without it. Yeah, see, it's jumping all over the place because of the back EMF back into the let me see if I could. So it looks like, if I'm reading this right, now that's all over the place too. Anyway, I'm not entirely happy with this setup. Not the commutator itself, but the arm, the way I attach that. It kind of came out janky. I love this thing. This thing works freaking great. I've got bigger bridge rectifiers. I don't know what this one was rated for. I don't even know if it's on there. Let me see. Let me put you down here for a second. Turn on my light. Yeah, it doesn't really say what it's rated for here. This is a GBU 1510 rectifier. So, not sure what it's rated for. Alright guys, I'm not gonna bore you with watching this thing finally play out. I'll probably let you know later on how long it went for. I don't even know if I'm going to continue running it. Alright, thanks for watching. Ciao. So not for nothing, but this thing is still going. Part of me says, just unplug it and drain the cap. Another part of me says, let it go. See how long it'll go. And it's not slowing down. And it's definitely not hooked up to any power source. It's running completely off the super bank. Oops. I think I just messed something up. Hold on. Yep, still running. There's my new wire holder thing that I printed out. I'm going to print out a bunch more and have them run around the corner there. Oh man, I don't know why I don't just stop this thing. Part of me is like, just stop it, dude. Another part is, let it go. Alright, but anyway, thanks for watching. This is really, I'm not going to bring you back again. Holy crap, I just unhooked it, right? Figuring it must be down to like 3 volts. It's still at 12 volts. This thing could probably run for hours. That's crazy. I didn't realize that supercaps held their juice that long. And it could be too because this is a Newman motor and doesn't need a lot to run. But wow, 12.3 volts and holding. Wow, I could have probably ran this thing, like I said, for hours. That's crazy. Anyway, I just thought I'd show you guys that. That's nuts. Ciao.